Okay, guys, let's do this. This is a big one here. I hope I'm gonna insist everyone watches this video before class. So we have solutions to systems. We're gonna solve them by graphing, substitution, and elimination. And even if you just went into the school year knowing that there's 3 ways to solve a system, you would have a head start. But we're gonna try to do even more than that. Okay, so the first thing is checking your answer. You can always know when you have the right answer to a system because just like an equation, substitute it back in. So I have my 411 is what they're asking me, is that the answer? So I know that 4 is an x value and 11 is a y value. I'm just gonna write x, y there, and all we're gonna do is substitute those things in for x and y, and then we'll talk about if we have the answer or not. So for y, I'm gonna put 11 equals, and then 4 times that, there's the x, and so I'm gonna put a 4 minus 5. Now I'm gonna simplify on this side, so 4 times 4 is 16 minus 5. 16 minus 5 is 11. Hey, that's what there was on the other side. So that checks. Okay, now let's do the same thing over here for y equals 2x plus 3. But I'm going to substitute in for 11. So y is 11 equals 2, and then the x is going to be the 4 plus 3. Okay, 2 times 4 is 8 plus 3. 8 plus 3 is 11. Hey! It works in both of them. Because it works in both of them, it is a solution. And if it didn't work in both of them, then it wouldn't be a solution. Now, most times we don't have the answer handy. We have to solve for it. So the first way that you can try to solve for it is by graphing. When you are graphing, you can have 2 different forms. These both have the x and the y on the same side. So this is called standard form. And I want you to write down intercepts. Okay, 2 intercepts, x and y. So standard form, we have that both intercepts. These, see, look, the x and the y are on different sides. You notice that? That's called slope-intercept form. Slope-intercept. Okay, and so this one we only have the y-intercept only. So when we're graphing, we always use our intercepts and then whatever else we can. So I'm going to start with standard form. And so the way you get, when I do standard form, I write x-intercept, y-intercept, x-intercept, y-intercept. And it makes it so easy, all right? All you have to do is recognize what you have to do. If you know what you have to do, it's easy. So to get the x-intercept, we set negative 2x equal to negative 4. Because remember, the y is 0 at an x-intercept, so that's not even part of it. All right, then if you divide both sides by negative 2, you'd get x equals 2, right? Now, for the y-intercept, we take the y term, that's 2y, we set that equal to negative 4. I don't know what that little dot is there. All right. So if you divide both sides by 2, you end up with y equals negative 2. So those are my intercepts for my first line. So I'm going to put the x-axis at 2 and the y-axis at negative 2. And then I'm going to draw a line through those guys. And now when you're graphing, if you were to do this on paper, you'd want to not just freehand it. You would want to use a ruler at the edge of a notebook or something. Now this next one I'm going to do in blue. So we got, we got 3x and we have negative 18. So we're going to do 3x equals negative 18 for the x-intercept. And I have some space to show my work in this one. So just in case you didn't know how I was getting from the equation to the answer, I was just dividing. So that goes away. And we have negative 6 for our x-intercept. So I'll go ahead and plot that. There's negative 6 on the x-axis. And the y-intercept, so 3y, positive 3y equals negative 18. Oh, it's the same. So when I divide by 3 again, I'm going to get the same answer again. But this time, I'm going to put that point on the y-axis. And now I'm going to draw my line through the 2 points. Okay. So it's not perfect or anything, but the solution to the system of equations is where the lines intersect. So and ignore these 2 lines. They're just part of the computer problem. But right there is that is the solution. Remember in the first problem we just did, the solution was a coordinate. Well, that's the coordinate where the lines intersect. So it looks like negative 2, 4, negative 4. That is the solution. So we put negative 2 for y or x and negative 4 for y. Okay, so that is in standard form where you do the simple one-step equations to find the intercepts, plot those points, draw the line, where do they intersect? Slope-intercept form is hopefully you are ready to graph in slope-intercept form. So we're going to start at the y-intercept. At y-intercept, move using slope. We did this in an assignment this past week. Okay, so we're going to start at negative 4. And our slope here is 1 because there's no number in front of the x. So our y-intercept is negative 4. And so I put a point there already. Now my slope is 1, so I'm going to go up 1 over 1, up 1 over 1. And I can keep doing that. And I can use my little line tool to draw a line. Okay, that's gotta be what it is. Now let's get a different color. And so for this one, the y-intercept, the first thing I notice is 2. So I'm going to put point at 2. And the slope here in the second one is 4. So now I have to, from that point 2, I have to go up 4 over 1. Remember, if it's a number, you can always put it over 1 to make it a fraction, because we know the slope is rise over run, right? So we're going to go up 4, 1, 2, 3, 4 over 1. And now we have our 2 points, and we can connect them to form a line. All right. Now, I'm going to have to be more precise than that because it looks like the solution is all the way down there. So where are these lines intersecting? Looks like maybe I didn't draw the best lines, but maybe they intersected -7, -3. If I was exact, you'll have to find out if they're intersecting it when you draw nice lines with the computer or on your paper if they intersect there. Let's see if I can, there we are. -7, -3. So our x is -7 and our y is -3. All right, 2 more. Stay with me. Or you could pause and then come back later, finish the video if you feel overwhelmed. Or some people like to watch just a part of the video for each assignment, and then they do that assignment, and then they watch the next part. I guess that's probably what I would do. All right, so systems of equations with substitution. So substitution means we're going to take, there's a no graph, we're going to take one equation and substitute the equation into the other equation. Usually you substitute a number into an equation, but in systems of equations, we go further than that. So the first thing you want to do is identify your forms. What you got? You got something that looks like slope-intercept or standard. Remember now when you're figuring out if it looks like slope-intercept, it can be, that is y equals mx plus b. That's what slope-intercept is. But when you're doing substitution, if it's x equals my plus b, that still fits the slope-intercept category. It's just that in standard form, both variables are on the same side. Okay? So can you guys find the standard form? Hopefully you're saying this is standard form because the x and the y are on the same side. That's it. Now this, the x and the y are on different sides. So we're going to call that slope-intercept. And the reason we're going to do that is because the second thing that you do is you take I always call it the mx plus b part and sub into standard form. So if you can figure out what standard form is and what their slope-intercept form is, then you put that mx plus b part into standard form. If they're both in standard form, you could solve one to make it slope-intercept form, or you could use another strategy. But here we have one of each, so let me just write the equation over, and then I will solve it. 2y minus 15. So what I do is I always circle the mx plus b part, and now you see it's my minus b. But in any case, it's what x equals. That's what it says. So we are going to put this in for x because it says x equals that. So now I'm going to write -5. How many times we use a different color? So take this thing, we're going to substitute it in right here. Okay, so -5 2y minus 15 plus 4y equals 3. So you see, I just wrote this first equation, but instead of writing x, I wrote 2y minus 15 because it says x equals that, so I can write x, or I can write 2y minus 15. But when I write 2y minus 15, how many variables do you see on this left side? You might be saying 2, but there's actually only one letter. They're both y's. So that means we can solve it. Okay, so hopefully you're like, oh yeah, distribute. Okay, so we're going to distribute, and then 5 times 15 is like, 75. 2 negatives make it positive. Okay, -10y plus 4y is -6y, combining those like terms. You can see this is why in week 1 we started out with multi-step equations. Now I'm going to subtract 75, make it -72 equals -6y divided by -6. and then that the two negatives make a positive. I know 60 is 10, that's 12. Okay, so y equals 12. Okay, so I guess the third step would be to solve. And then the fourth step is to sub back in to get other variable. Don't ever forget we have two variables. All right, so now we got y. So now we know that x was just 2y minus 15, right? 2y minus, so now I'm going to write 212 minus 15. 24 minus 15 is 9. X equals 9. So 9, 12. And then you could substitute that into both of them, and it should give you the same thing. All right. So maybe you took a break there, but now we're going to do this last one. And this is some people's favorite, elimination. Okay. So now I'm wondering if you are already looking at these equations and saying, oh, they're in standard form. I mean, that's what I'm doing. The x and the y are on the same side. So when both are in standard form, this is the one when both are in standard form. Okay, so what do? You add those equations together, combine like terms. 5y and 7y, 5y and 2y is 7y. Negative 4x plus 4x, that cancels out. Negative 7 plus 14 is 7. So now we just have 7y equals 7. Y equals 1. Goodness, that was easy. All right, then we substitute that back into the, I just picked the top equation. So 5 times 1 minus 4x equals negative 7. Okay, 5 minus 4x equals negative 7. And then I just solve the equation. So that's negative 12 equals negative 4x. And guess what? If you say to yourself, this is too much, you're going to have to do this over and over again in high school. So work hard at it right now, because I even taught seniors in high school how to do this, and they had already seen it in Algebra 1, Geometry a little bit, Algebra 2, and then their senior math. So, you know, work hard, figure it out. It's not that bad once you get it. So this one we have it. You may be saying, Mr. Field, what you talking about? That was easy. I just added the equations together. The x is canceled out. All I had to do was divide to get y, and then I substituted and solved a two-step equation. All right. Now, the thing about elimination is sometimes it's not set up, it's not ready for you. So you see the x and the y are on the same side, but so are the numbers. Well, that's silly. Okay, so how can we get the numbers on the side they're supposed to be? Let's do that first. So we could just add 54, or some people just say, oh, if I put it on the other side, it's just the opposite sign. Okay, so then we can do that with both of them. 5y minus 2x equals positive 34. Okay, so now at least variables on one side, numbers on the other. But still, if I were to add these together, the y's would be 8 and the x's would be 8. But we want one variable to cancel. So what we can do is pretend like least common multiples, common denominators. You have to think like that, okay? Think about your common denominators. I could do, the x's would be easier, but I'm going to do the y's to prove my point. So what is the common denominator of 3 and 5? It's 15. It's the least common multiple is really what it is. So what we want to do is get them both to be 15 through multiplication. So what do I need to multiply 3 by to get 15? I need to multiply it by 5. And what do I need to multiply 5 by to get 15? I need to multiply it by 3. 3 times 5, 5 times 3, same thing. And then if I want them to cancel, just make one negative, and then when you add them together, go to 0. So now we distribute to all 3, and then write the equations. 5 times 3, negative 5 times 3 is negative 15y. Negative 5 times 10 is negative 50x. And negative 5 times 54. Oh man, that's too large for me to do. Oh, let me get a mistake. It's 270. I'm not good at that. All right. 3 times 5 is 15. 3 times negative 2 is negative 6. 3 times 34, 102. Mistakes are okay. All right, so now we can add them together. The y's cancel. We get negative 56x. And then we're going to get, is it 270, right? So that's 168. Negative 168. And then what is that? 2? 3? 168 divided by 56? 3. Divide both sides by negative 56. X equals 3. Then you just substitute that back in. I'll pick the top equation again. So 3y plus 10 times 3. So this is 10 times 3 minus 54 equals 0. All right. So then 3y plus 30 minus 54 equals 0. 3y minus 14 equals 0. Is that 14? 54 minus 30. Oh, is that 24? 24. All right. Thank you. All right. So 3y equals 24, and 3y, when we divide that by 3, we're going to get, I bet some people already know it, 8. 3. So 3 and 8. All right, there you go. Try every assignment one time and then come to class with your questions, and we are going to have some fun.